So here we have a boy sliding down a hill, accelerating at 1.4 meters per second squared. If he started from rest, in what distance would he reach a speed of 7 meters per second? I feel like I should be making that bigger to read that. How far does he have to slide before he reaches 7 meters per second? Okay, well, let's have a look. What do we know? We know our acceleration. He started from rest, that is our initial velocity. In what distance? So I'm solving for d, and I've got a speed of 7 meters per second. That's going to be my VF, my final velocity. What formula do you think you're going to use with VI, dA, and VF in? I don't have time. The third one, is it not? It's the only one that's got acceleration and distance without time in it, right? So I think it's just I think it's just VF squared equals VI squared plus 2AD, right? And again, I urge you to write the formula, to line up the equal signs, right? Substitute, all that good stuff. We're going to be getting to like 7, 8, 9 step problems. So you're going to have to start doing that. It was funny for a while, but it's not funny anymore. 7 squared, what's my VI? 0. Acceleration, 1.4, and the distance is 7, right? What am I solving for here? Oh, yeah. We don't have distance. There we go. 7 squared is, of course, 49. 0 squared is 0. 2 times 1.4 is 2.8d. And I'm really hoping everyone can just solve this, maybe like not the arithmetic, but you know what to do. 49 divided by 2.8, 17.5 meters. Not that exciting. Makes sense, right? This problem solved. Any problems or concerns? That's pretty straightforward, right? Yeah. All good? Okay, now I got a plane. Brandon, put it away. You just had, you were just in contact like 10 minutes ago, man. A plane starting from rest at one end of a runway undergoes a constant acceleration of 1.6 meters per second squared for a distance of 1,600 meters, which just happens to be a mile. Before takeoff, what is the speed upon takeoff, and what is the time required for takeoff? How long does it take to get that far? Let's see what we've got here. Starting from rest, initial velocity 0, right? Acceleration is 1.6. Distance is 1,600. What is the speed upon takeoff I'm solving for? VF. What is the time required for takeoff? Solving for T. Again, which one has VI, VF, A, and D in it? That's special equation number 2. 3. VF squared equals VI squared plus 2AD. You will remember the formulas if you write them down. You say them out loud or sing a song or whatever. I remember them because I've been using them for 30 years. No, I can't. Solve for final velocity. Initial is 0. Acceleration 1.6, and my distance is 1,600. Make sure you take the square root. I get 71.5 meters per second. Final speed, 71.5 meters per second. Does that seem reasonable? 70 meters per second? How fast is that in kilometers? Times by 3.6, 257.4 kilometers per hour. Is that about how fast a plane goes at takeoff? 357 kilometers an hour? I would think so, right? Maybe even faster. What is the time required for takeoff? So part B. So I'm looking for one with T in it, right? First one or the second one? Or will they both give you the same thing? Should give you the same thing. I'm going to go with VF equals VI plus AT. Final velocity 71.5. Initial is 0. Acceleration was 1.6. Solve for T. $71.5 divided by 1.6 is, what is it? 44.7 seconds. Does that seem reasonable? How many people have been on a plane recently? 45 seconds to take off, does that seem reasonable? When you're sitting there and then, the pilot takes off, is it?
Well, most of them aren't a mile long.
Okay, so 45 seconds seems a bit long, right? So what do you think is wrong about the question? Like, what's not a valid assumption? 1,600, would runways be about a mile long?
Yeah.
I would think they'd have to be pretty close.
Really fast plane. And it has to speed up, though, so it starts at 0.
It has to start at 0, so what's the other number that's given? Do you think 1.6 is a valid airplane acceleration? When you start off, it kind of,
Yeah.
right? But then when he or she, right, puts the pedal down, I don't think it's a pedal. Yeah, right? I'm guessing they're accelerating more than 1.6, right?
It'll vary by airplane, but it should be close enough.
747? Acceleration of a B747. About 15 seconds. Oh, that's a guess.
Okay,
51 seconds to finally take off at speed 280 kilometers an hour. Huh. According to this dude from Germany. Is that accurate information, do you think?
Well, a couple people said that.
Well, so 2 people said it.
Yeah. So I trust those 2 people.
Yeah?
They showed for founder or just oh, just let's say.
That's upon landing. I don't know. Takeoff speeds and aircraft performance. Decoded science. That seems like we can trust that.
There'll be another 4.
Takeoff speeds. Holy. I don't know. I can't find it.
Well, I trust those 2 people from